I'd like to take you through an example of your project. I am going to not do clay, but I will do a sample project on determining the density of gravel. But everything that we do as far as the collecting of data and the graphing, it would be the same. So I'm going to assume that you already have a Science Skills project data sheet completed for your project, and that you have weighed your clay with the triple beam balance, and that you have done a volume by displacement measurement for the same clay and completed this part of the document also. Just a few things that I look for when I check your data is I want to make sure that you have recorded the precision of your instrument, and remember, precision is half of your smallest graduation. So for the triple beam balances that we have in the classroom, the smallest tick mark, or smallest graduation, is 0.1, so the precision is 0.05 grams. Here are my 4 mass measurements for my gravel. I have gravel of different sizes, and I started with the smallest one first. What I'm going to be looking for on your data is, did you record the proper number of significant figures? So if the scale can measure to 0.05 grams, then I want to see 2 digits to the right of the decimal for all your mass readings. So I'm looking for your precision, and that precision represented in the number of significant figures that you record for your mass. For my experiment, I used the 100 milliliter graduated cylinder. It's smaller than the larger plastic ones that I have in the classroom, because some people were getting the clay stuck in the smaller ones. But my data is based on the 100 milliliter graduated cylinder size. That's just the total volume of the cylinder when it's full. The smallest graduation on the 100 milliliter graduated cylinder is 1, and so half of that, my precision, is 5 milliliters. Just a side note, which is important to you, that if you were using the 250 milliliter plastic graduated cylinders in the classroom, your smallest graduation was 2, and your precision was 1 milliliter. So again, I'm going to be checking for your precision, and then I'm going to be looking at your readings. There seemed to be some confusion on making volume by displacement measurements. This was the case where our initial readings was with just putting a random amount of water in the graduated cylinder, and then when we dropped our clay, or in my case the gravel, in, then the volume went up. And so to get the actual the volume of the solid that we put in it, then you have to subtract your final reading from your initial reading, and that's where we get the final minus initial numbers over here. So you see that first I had 25.5 milliliters of water in my graduated cylinder, and then it went up to 27.5. So if I subtract my final from my initial, then my smallest piece of gravel had a volume of 2 milliliters. And so I repeat that for the small and the medium and the large, recording the volume of the gravel, each piece of gravel. So looking at the number of significant figures here, you can see where I have not recorded my numbers as precise, and I need to fix that. I did on my initial readings and my final readings, but I didn't, you see I have 1 digit to the right of the decimal here. I need to have 1 digit to the right of the decimal over here. So, you know, it's common for people to think, well, this is 2.0. Do I really need to include that 0? Yes, you do, because that you're indicating the precision of your measurement.